Welcome to this video on estimating a population mean. By the end of this video, you should be able to construct and interpret a confidence interval for a population mean using the four-step process. Alright, so what I want you to do, pause the video, and in 60 seconds, write down as many states as you can remember. Come back when you're done. Alright, how'd you do? Hopefully you did pretty well. We'll see if you fall into our confidence interval or not. So, how many states can you name in 1 minute? We're going to use the class as a random sample of all AP students to estimate a 95% confidence interval for the mean number of states an AP student can name in 1 minute. So you've already done your timer. Let's see how we compare. But first, the question is, what type of data is this? Is it categorical or is it quantitative? Well, this data is quantitative because we got a number of states. Okay. For our sample, what we got is we had 32 people naming states. We had a sample mean of 16.183, and we had a sample standard deviation of 5.527. Okay. So I'm going to make a dot plot of the data, and then I'm going to have you pause the video to copy this down. All right, here you go. Go ahead and pause the video and copy this down and come back when you're ready. All right, now that that's written down, we're going to construct a 95% confidence interval to estimate the mean number of states a senior can name, or junior, since we also have some juniors. Okay, so in your state, you always have to state the parameter that you want to estimate and a confidence level. So we're talking about the mean number of states, so you want to use mu, and it's the true mean number of states an AP Stats students can name in 1 minute. Okay. Our confidence level is 95%. Okay, so our procedure, it is a one sample. So we call this a one sample. Remember, these are T intervals for mu. And we're going to check some conditions. So we have random. So technically you were a convenient sample, but we're going to go with that. We're assuming you are a good representation of AP students, AP Stats students everywhere. So we're going to assume random. Then our 10%. There were 32 students. That should be less than 1/10 of all AP Stats students. Okay. And then we can just call this normal over here. We called it large counts when we were doing our proportions, normal, large sample. It just depends. There's 3 ways we can determine this that we'll talk about a little bit more soon. Okay, and we had 32 students, which are greater than or equal to 30. So the central limit theorem that I'm going to abbreviate CLT means it's approximately normal. All right, if the conditions are met, so why did we check these conditions? Okay, why is this important? Let's just stop here for a second. So remember, you want random, so you can generalize to the population. The 10% is so we can use that standard deviation. It's going to be a standard error because we're using the information from the sample, where you have the sample standard deviation divided by the square root of n. And normal is so your sampling distribution of x bar is approximately normal. All right. Now, let's keep going forward. For our do part, we're going to go and perform all of our calculations. So the general formula is just really the words. Okay, so we're looking for a confidence interval. You always use the point estimate plus or minus the margin of error. Okay. For this specifically, what it looks like, because that could be for a proportion or means, it doesn't matter. For means, it's going to look like x bar plus or minus your t star times the standard deviation of the sample divided by the square root of the sample size. Okay, so before we go any further, we're going to plug some numbers in. For our t star, we had a sample size of 32. Degrees of freedom equals 32 minus 1, which is 31. But if we look at our handy-dandy table, there is no 31. So remember, you always round down. So we'll end up using a degrees of freedom of 30. Which will give me a t star of 2.042 when I look it up for a 95% confidence interval. Okay, so our point estimate, when we plug everything in, was 16.813. We're going to add and subtract our t star, which is 2.042, times the standard deviation of the sample was 5.527, divided by the square root of the sample size, which was 32. And when I put this in, I ended up with an interval of 14.818 to 18.808. Okay, I'd like you to pause the video, write your conclusion, and come back to see how you did. All right, so we are 95% confident the interval 14.818 to 18.808 captures the true mean number of states an AP Stat student can name in 1 minute. Did you fall into that confidence interval? That would be an interesting, what would that mean if we were doing a significance test? If you're in it, that would be a fail to reject. If you're out of it, we would be rejecting. All right, so let's take a look at the back of this to summarize what we've got going on. All right, for our four-step process, state, plan, do, conclude, for our confidence interval for means, in our state section, you want to define your parameter. And you want to name your confidence level. Okay, make sure both of those in there. For our plan, our procedure is a one sample t interval for means. And you want to talk about random. So you would say it's a random sample of whatever. Okay. Then you have your 10% rule. It's where your n has to be less than or equal to 1/10 of the population. And then we had normal. So normal has three ways this can happen. Okay, so They're differing levels. We talked about it in the previous video. We could have one way that the population is approximately normal. If that's not stated, 2 is if your sample size is greater than or equal to 30, you have the central limit theorem that is enacted. And then your third one, this is if you have the sample data. A graph shows no strong skews. Or outliers. Okay. So for the normal, it's either the population is approximately normal, you have the central limit theorem enacted because your sample size is big enough, or if you have the sample data, you graph it and it shows no strong skews or outliers. So that's kind of the order. This should be the first thing you look for. If that's not there, then look for CLT. If CLT is not there, then you're going to look for the sample data. Okay. Now for our do section. In your do, you'll have your formulas and your work and your answer. Okay, and the formula that you'll use is that's your point estimate, X bar, that comes from your sample, plus or minus your T star times the standard error, which is the sample standard deviation divided by the square root of n. Don't forget to include, you need to write it down, your degrees of freedom, which is 1 less than your sample size, round down if you need, if it's not on the table. Okay. And then we have conclude, and that's your, we are blank % confident statement. Whatever your % is, and make sure everything's in context. One thing I want to mention, if you're finding your sample size, you'll be using the margin of error equals your critical value times your standard deviation. Okay. The problem you may face here is if you're looking for sample size, you can't get a T star. You can't get a critical value because it's all based on sample size. So when you don't know sample size, use the Z. So if you're doing a 95% confidence interval, you would plug in 1.96 right here, and then you're going to solve for n. So the problem is you must know the sample size to get your critical value. So if you're trying to determine what your sample size should be, there's no way you know the critical value. So you would just use whatever Z was appropriate for that confidence level. All right, so that will actually be what you do in part A down here. You're looking for a sample size, so it tells you the margin of error, it tells you the standard deviation. What you're looking for is a sample size, and it wants a 95% confidence level, so your critical value would be 1.96. All right, give the Check Your Understanding a try. Check your answers on Canvas. Let me know if you have any questions, and I'll see you in class.